Welcome to the online lecture series on 8051 microcontroller. We shall start with the branching instructions. Before we discuss about the branching instructions, let us first understand what is sequential flow of execution. See, we started with the instruction. An instruction is a command to the processor, and we saw many types of instructions. We saw data transfer, arithmetic, logical, bit manipulation. Fine. So a group of instructions, it forms a code. Okay. So when you write a code, the processor starts executing from the first instruction. After executing the first instruction, the processor then executes the second instruction, then the third, and so on. So this way of executing the instructions one by one, it is called as the sequential flow. The program counter, which is a 16-bit register, it keeps tracks of these addresses. Okay, let us first understand this with an example. As you can see, I have written some dummy code. It doesn't have any logic. The purpose is only to explain the sequential flow. I have around 6 instructions excluding this sjump instruction. So I will execute this and we shall see what is the meaning of sequential flow. Fine. Now, the program counter is at 000h because we have started the code at 0h. Now, we are at the first instruction. Okay, so I will execute the first instruction. Then, now the program counter, it is pointing to the address of the next instruction. Okay, so program counter now is 02. Why? Because this instruction takes 2 bytes, one for the opcode, the other for the immediate data. That's why this address was 000h. So 000h plus 2, it becomes 02h. If I execute again, you can see the second instruction has been executed, and now the program counter is pointing to the third instruction. So this way of execution, where each instruction is executed one by one, we call it as sequential flow of execution. Fine. So almost all the codes are sequential in nature, unless there is a branching instruction which occurs in between the code. So whenever there is a branching instruction anywhere between the code, it breaks the sequential flow. Fine. So a branching instruction is one which anywhere it occurs between the code, between the instructions, it breaks the sequential flow. Then what it does? Then it branches to a new address, which we call it as the branching address. So the program counter now contains the branching address. The third is the execution of the code continues from the branching address. So 3 things you have to remember with respect to a branching instruction. First, it breaks the sequential flow of execution. Second, it branches to a new address, which we call it as a branching address. Third, now it starts executing the code from the branching address. Okay, so this will be more clear when I discuss with an example. Okay, let's take an example. Now this was the normal code. What I will do is I will introduce a branching instruction called sjump. Sjump, it stands for short jump. Okay, and this is called as the label. Okay, so a label cannot be a keyword. Okay, what is the meaning of it? I cannot write it as add because add is a keyword, it's a mnemonic. Fine, you can write add1 because add1 is not a keyword. Okay, so I will write something called next, and the label I will mention it here. Okay, how do you mention the label? You have to write the label name, then colon. Fine. Now, what does this instruct? Now, what I have done is, in between somewhere, I have introduced a branching instruction. Okay, how the details of this sjump instruction will be discussed later. Okay, as of now, you understand that I have introduced a branching instruction somewhere in between. Okay, what does this instruction do? You start executing from the first instruction, you will execute the second instruction. But when it comes to the branching instruction, fine, so it branches to this new branching address. Okay, now when this instruction is executed, now the control is transferred here. The program counter now contains the address of this instruction, that is increment or not. After this, the execution continues from increment or not. So these instructions will not be executed. Okay, we shall execute this and it will be more understandable. Okay, now see here, I have executed the first instruction, I have executed the second instruction. What should have happened? The sequential flow should have continued, but the sequential flow will not continue. Fine. Why? Because I have a branching instruction in between. Okay. Now, what does the branching instruction do? I told three things. First, it breaks the sequential flow. Second, it branches to a new address, which we call it as a branching address, and the contents of the PC are also replaced by the branching address. Third, it continues the execution from that branching address. Okay. Now let us see that. So when I execute this, can you see? First, it has broken the sequential flow. These instructions have not been executed. Second, it has branched to the branching address. Fine. So this label, because of this label, it has branched to the branching address. Okay. As you can see, the program counter now contains the address of this branching address. Okay. Now, the third is the execution starts from this branching address onwards. Fine. So this is about the branching instruction. There are various types of branching instructions. I have started with the simple one so that you understand the concept of the branching instruction. Okay. Let me do it again. Okay. I executed the first instruction, second instruction. Now I have got a branching instruction. So this will break the sequential flow and it will go to the label which is mentioned here. Okay. So it has broken the flow. It has got to the new branching address and the execution continues from this point onwards. Fine. So in 8051, branching instructions are classified as unconditional jump instructions, conditional jump instructions, and subroutine instructions. Okay. In module 2, we shall be discussing unconditional jump instructions and conditional jump instructions. Subroutine instructions will be discussed in module 3. Fine. So in the next class, we shall start with unconditional jump instructions. Thank you.